Hello everyone, this is Mr. Appel, and today we're going to do a little review of solving a few kinds of equations, linear and quadratic. Most of this is review, some of it going back as far as Algebra 1, so some of this I'm going to go through very quickly. So if you need to pause and rewind and just kind of revisit, if you need to go on Khan Academy and do some practice because you don't remember any of this, do that. But this is stuff you should be pretty comfortable with. I'm going to go through that first part quickly and then go a little more slowly through some things that you either haven't seen at all or have only spent a little bit of time with. So here we go. First, linear equations. I'm really not even going to talk about that. You've been doing this since Algebra 1. Distribute, combine like terms, all that good stuff. You're going to see this problem on Schoology in a few minutes when you're done with this video. So I'm not even going to bother with that one. I'm hoping you know how to do that. So let's get to quadratics. So quadratics, you may remember standard form for quadratic is when we set it equal to 0 and put it in order from highest degree down to lowest. Remember that a, b, and c are real numbers, and typically we use rational coefficients, although they don't have to be. So one type of solving quadratics is where you are able to square root both sides. Now this typically happens, as it says here, if there's no linear term. So in other words, if there's no x term, if there's no this term, that's one clue that you can do this. So you just take the square root of both sides, and you're left with x equals. Remember, when you take the square root of both sides, this is really important. There's two possible answers. It's not just 7. It's positive or negative 7. So you have to remember that plus or minus when you take the square root of both sides. Another example here. So this one, you'd want to get the x squared by itself. So you'd have x squared equals 20 over 18. I might reduce that to 10 over 9. Sorry, x squared. And so now when I take the square root of both sides, I can simplify that. It's a plus or minus. See, I almost forgot it. So we get plus or minus around 10 over 3, because square root of 9 is 3. Piece of cake. Okay, and one more example. This is kind of convenient because we have 4x minus 1, but the whole thing's squared. But we still have something squared equals a number. So you can still take the square root of both sides. So take the square root of both sides, because square rooting and squaring cancel each other out. And what are we left with? We're left with 4x minus 1 equals plus or minus 32. From here, you got a little bit of work to do, but we can find two solutions. So we have two possibilities. 4x minus 1 equals positive 32, or 4x minus 1 equals negative 32. And then we just solve each of those equations. So 4x equals 33, excuse my sloppy handwriting. So that's 33 fourths. Or 4x minus 1 equals negative 32. Add the 1, so that's 4x equals negative 31. Divide by 4, and we get negative 31 over 4. So those are pretty easy to do. Most equations don't work out that conveniently. But just something to pay attention to moving forward. When an equation looks like this, something squared equals a number, easy to solve because you can square root both sides. Keep that in mind because we're going to come back to that in just a second. Okay, solving by factoring. Do I really have to review this? We did a bunch of this in the summer assignment. No, I don't think I'm even going to review that. If you have questions about it in class, you can ask or take a quick look for solving quadratics by factoring on Khan Academy if you're really stuck. But that's review. We've been doing that. I think you know how to do that. Okay, now let's get to something slightly more interesting. You may not have had as much experience with this. So when we're solving an equation like this that has rational coefficients, we've got some kind of unpleasant denominators here. And so one strategy for solving this is to get a common denominator, or actually just eliminate the denominators. So if I multiply this entire equation by the least common multiple, in other words, basically find a common denominator, it becomes much easier to solve. So if I were going to find a common denominator for all three terms, I see 2, 15, and 10. 30 is the least common multiple. So if I'm to multiply top and bottom of this one by 15, multiply top and bottom of this one by 2, and multiply top and bottom of this one, by 3, what I have left is on the top, I have 15x squared over 30 equals 4x over 30 plus 3 over 30. And since everything's over 30, well, I mean, an easier way to think about this is if we just multiply everything by 30 now, what happens? The 30s just all go away. And so we're left with a quadratic equation, 15x squared equals 4x plus 3. And we can now solve that by factoring or quadratic formula or completing the square. In this case, it's factorable. 15x squared minus 4x minus 3 equals 0. And then we can solve by factoring, which I'm not even going to finish, but trust me, it is factorable. If you want to try that for practice, go for it, and you can impress me tomorrow. Okay, moving on. Let's get to the good stuff, the quadratic formula. Hopefully you remember the quadratic formula. If you don't, there it is. That is one of those things you need to have memorized. So there it is. Remember to use the quadratic formula, A, B, and C in that formula. Assume that it's in standard form. So if I wanted to solve this problem using the quadratic formula, I've got to put it in standard form first. So I'm going to distribute. So I have x squared plus 7x equals 14. Go ahead and subtract. So that's 7x minus 14 equals 0. And looking at that quickly, I see it's not factorable, so quadratic formula is probably a good bet. So let's see what that looks like. So x equals, so a is 1, b is positive 7, c is negative 14. So negative b, that's negative 7, plus or minus square root of, and I like to actually set up the parentheses here so I don't make any mistakes with signs. All over 2a, so that's b squared, so that's 7 squared, minus 4 times a times c, which is the negative 14. Oops, almost forgot here, all over 2a, a is 1. So that is going to equal, on the top, negative 7 plus or minus, let's simplify all this, so that's 7 squared, that's 49. Negative 4 times 1 is negative 4. Negative 4 times negative 14. 14, 20, that's 56. So that's 49 plus 56. So 49 plus 56, which is 105, if I'm doing that correctly, all over 2. Okay. And then you'd want to look and see if the square root of 105 can be reduced. So if you could simplify that radical at all, and if you can, you would do that. But in this case, it's actually not, it can't be reduced. If you try to simplify, excuse me, not reduce. If you try to simplify that radical, it can't be simplified. So this is as much as you can do. We'll talk more about how to simplify expressions like that further when they can be simplified, but that one can't. Whew. Okay, moving on. We're going fast today. We got a lot to cover. Hopefully you're keeping up, and this is all coming back to you. Completing the square. I'm going to go through this one a little more carefully because you may not be as comfortable with it. Again, you might need to refresh your memory, review a little bit. So completing the square is the only one that we don't want in standard form. The basic idea is we want to make this equation look like what we saw earlier, which is something squared equals a number, because once it looks like that, we can easily square root both sides. So we're going to use this little process called completing the square to make it do that. So what I'm going to do is I'm going to keep the x squared minus 4x over here, and I'm going to move the 2 over to the other side, so subtract the 2. But notice I'm going to leave a little space right here. And I'm doing that because I'm trying to figure out what number could I stick here so that this, wow, that is a really hideous looking 4. Even for my handwriting, I can't read it like that. So I'm going to fix that. Okay. So what number could go there that would make this side factor to be a perfect square? And you may remember the little trick is it's just the b value, which in this case is negative 4, divided by 2 squared. And if you take that b value divided by 2 and square it and put that number here, so in this case that's negative 2 squared, which is positive 4, and put that there. Now if you factor, if you factor that left side of the equation, it factors, try that again, sorry. It factors to x minus 2 times x minus 2, or x minus 2 squared. We just completed the square, hence the name, haha. But of course you can't just add 4 to one side of the equation, you have to do the same thing to both. So now that equals 2. Now we can take the square root of both sides, and we're left with x minus 2 equals plus or minus rad 2. We got trying to solve for x, so we add the 2, so we have 2 plus or minus rad 2, and since you can't actually add those together, perfectly appropriate to just leave your answer looking like that. Okay, that is completing the square, and I think that's where we will stop today. Have a good night.